Hello, welcome. Today let's try to solve another Leetcode problem, 279 perfect squares. So we are giving an integer n, returns the least number of perfect square numbers that sum up to n. So this means if we are giving a number 12, so what is the least of square numbers that sum up to this 12? So it will be 4 plus 4 plus 4, so it will be 3. If we use 1, so 1 plus 1 until 12, we will use how many? We will use 12 numbers. If we use 2, 4, and others we use 4 ones, so it will be 1 plus 1 plus 4, it will be 6. But the minimum is 4 plus 4 plus 4. Yeah, so it is 3. You cannot find any other numbers. Yeah, so for example, if you choose 3, square of 3 is 9, but it left behind is a 3. So for 3, you cannot find any kind of numbers. Yeah, so this problem is like Leetcode coexist 1 problem. So for coexist 1, we are giving an amount. So amount is the maximum of value. We're gonna sum up to this amount. And we are also giving some kind of coins like 1, 2, and 5. So that's the value of the coins. We need to calculate the minimum of coins we need to make it sum up to the amount. So that is the unbounded knapsack problems. And for this, it's exactly the unbounded knapsack problems, and it's exactly the same as coexist 1. So for here, this n is the amount, and the square numbers is just an array I prepared. The squares is I times I for I in range 1 to 100. So this is according to the value of n. So it means for the I, it will be from 1 to 100. So this is the squares. So inside the numbers, it will be like 1, 4, 9 until to 10 to the power of 4. So this squares means the value of the coins I have. Yeah, so this is the coins, and this n is the amount. So this is an unbounded knapsack. So normally we do it like we will prepare a DP array. So the first value will be 0, and then for others I will give n because n is the maximum of the value. It's 12, so it will not influence my result. And then or you can give other numbers, it doesn't matter. So this n just means the maximum, yeah, of the values I can have. For example, this n equals to 12. If I choose 1, it will be 12. So for the DP array, I'm going to use the 2 for loops. The first loop is the outer loop for I in range from 1 to n plus 1. So this is for updating the DP array. So then I'm going to choose the coins from the squares. So here I'm going to choose the numbers for x in squares from the squares. So if this I, the index, yeah, it also means my DP array. Inside my DP array, it means the value. If this value is more than or equal to x, yeah, I will update my DP array. So the DP array needed to equal to the minimum of DPI. So this is the previous one. Now I'm going to update with I minus x, because if I find x, this I minus x will always be more than and equal to 0. Yeah, because this I minus x is more than and equal to 0. This is why the DP array always works. It will not go out of range. And then this one means I choose a number, or I choose a coin. Yeah. Finally, I just need to return the DP minus 1. So that will be the minimum of numbers I can choose, or the minimum of coins I can choose for the coexist 1 problem. Now let me run it to check if it works. Yeah, as you can see, it works. Now let me analyze the time complexity first. So the time complexity is this n, so this I, the maximum is n, times this square x. So how many numbers inside the squares? So there's 100. So 100 times n, so what is the value of n? N is 10 to the power of 4. So it means the maximum is 10 to the power of 6. So this means we can pass for the Leetcode. Now let me submit it to check if it works. Yeah, and by the way, the space complexity is just the maximum of DP array with the squares. So it is ON. So the DP array, the length of DP array is n. As you can see, it's pretty fast and it works. Now let me check something else. Yeah, about this kind of unbounded knapsack problems. So for this problem, why we're gonna define the first index as 0? I already explained the other index, normally it's gonna be n. Can I define the first index as n? Yeah, it also works, but then you're gonna also prepare the dp0 to the 0. Yeah, because I'm gonna loop through my dp array from the index 1, but the dp0 equal to 0 is my base case. So this means if my amount n equal to 0, yeah, normally n is more than and equal to 1, but I will use a 0 as base case for my dp array. So this means if I take nothing, it means n equals to 0. So how many, what is the minimum of numbers I can choose? Definitely it is a 0. This means I don't need to choose any numbers. Yeah, so this is why the first one is a 0. It's even the same for the coefficient 1 problem. So the first index should be 0. Yeah, and then I'm going to loop through the dp array. So inside this dp array, for this I is always more than or equal to this x. So I'm going to use this 0 to update my dp array. So for n equals to 1, so for example, so for n equal to 1, if n equal to 1, so from the 0, the 0 index is 0, then I'm going to choose the second index, it means the index 1. So for the index 1, I'm going to choose the minimum. So the dpi should equal to the minimum of dpi. So inside it will 1, and this I minus x. So I minus x is, this I is 1, and this x, so the first place is 1. 1 minus 1 is dp0. So dp0 is 0, so 0 plus 1. It means I'm gonna choose 1 coin. So this is why we are preparing the first index as 0. Yeah, it is preparing for our transformation function, so for this function. Yeah, so this means if we take, so for example, n equal to 4, yeah, and 4 is the square of 2. So it means we just choose this 4 as 1. And the dpi, 4 minus this 4, 0. So 0 plus 1, it will still be 1. So this is why we're going to prepare it as 0. This is for calculating the minimum of numbers. Yeah, I hope we understand by now. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problems like this. See you next time.